Good morning. Thank you guys for joining us this morning for our technical seminar hosted by WES. Today we're presenting Capturing the Future, Cameras, Storage, Displays, and Edge AI. Our presenter is Marty Miller. Marty graduated from the University of Minnesota with an electrical engineering degree. He developed microprocessor-based communication systems for 17 years, and he's been part of our team for the MFC group for over 22 years, supporting the sales of microprocessor-based subsystems and systems. So we're in good hands. He's a great technical resource for us. I'm Amanda. I am a product manager with WES. So I'm going to speak up for a little bit about the WES team, and then Marty will go through all of our technical info. And then at the end, we do have trivia. If you guys would like to stick around and play, we do have prizes for the top 3 winners. So you have a very strong chance of winning a prize if you'd like to participate. So with that, Marty, I'll turn it over to you.
Good morning, everyone. My name is Marty Miller, and thank you for attending today. Amanda gave a pretty good overview of what my role with the company is. I do want to say that I am not a camera expert. I'm not the right person to necessarily help you pick the right camera with the right lens and all of that, but Econ Systems has all kinds of technical support to help you with that. What I'm more familiar with on cameras is how customers are using them and why they're using them. Most of what I'll talk about today is based on something that a customer or more than one customer in our territory is doing. We also, why are we talking about cameras, storage, displays, and Edge AI? Well, camera is not real useful if you don't have something to display the image on so that the operator or the user can see it. So a camera without a display is typically not going to do much for you unless you're using Edge AI, and we'll talk about that in a bit. Typically, on most of these machines, the display is a smart display or a panel PC or human machine interface where it has a computer integrated in the display. So if you have a computer, you need storage. And if you have a computer, when the camera image comes in, you can make some basic decisions on what you're seeing and alert the operator, but not necessarily take action to actually prevent something from happening like you could do with Edge AI. So that's why we're talking about camera, storage, displays, and then towards the end of the presentation, we'll talk about Edge AI, which is really where cameras come into play in today's world a lot. If you have any questions along the way, please stop me and ask. And I'm going to turn it back over to Amanda for the next couple slides, and then I'll continue on.
Perfect. So this just gives you a little bit of information about WES. I know you guys are a little bit familiar with us already, but we've been around for 42 years, and we are located our main office is located in Cedar Rapids, Iowa. We cover 7 states, and we are a part of the entire MFC group. So we have 5 divisions as a corporate company, and we're an ESOP. So we're employee owned and love to share the responsibility of carrying our company forward. It's a fun part of our job. The WES team, we have 5 team members, and we have served over 225 satisfied customers. Next slide. So this just gives a quick snapshot of the states that we cover. We cover the states in blue, and the stars there are our main offices, so Cedar Rapids, Iowa, and Kansas City. And this is our team. So I believe you guys are familiar with Willie Sneller. So Willie, Butch, and Chris are our technical sales. Robin Mangold and I are both product managers, and we help to serve our customers more from the inside while the guys are out having the face-to-face meetings, and try to keep everything running from day to day.
And they do a very good job of it.
Thank you.
I'll just add that Mel Foster Company, the original company that has acquired all these divisions over time, is celebrating our 100th anniversary next week. So we're the oldest electronics representative in America. I'm not sure what we represented then, but I know it's not anything like we represent today.
And this is our full line card. So we do have lots of different RF component suppliers. And then we will be going through the camera and display and storage memory suppliers today.
All right, well, thank you, Amanda. These are the topics I wanted to talk about today. What industries use cameras? And then what applications are they using those cameras for? A quick overview of some of the different types of cameras that are available. We're going to talk about the typical physical hardware interface of the cameras and what the differences are, and where they're more appropriate for one use case than another. And then at the end, we're going to talk about how you can combine cameras with edge AI and local storage and displays, so you can make intelligent local decisions. And once you add edge AI, the edge AI computer can detect, for example, a situation where you're going to hit something that you don't want to with a vehicle, and stop the vehicle instead of just putting an alert up to the operator, like I talked about previously. So those are the topics for today. I'm going to talk about some of the industries that use cameras, and then I'll talk about how they're using them in another slide. But manufacturing is using cameras in many different ways. A lot of it's for manufacturing quality control. They'll be using visual inspection. They'll watch the operators or the assemblers actually verify that they're following the correct procedure. They'll look at the circuit boards as they're coming off the surface mount machine to make sure all the parts are in the right place with the right orientation. They can look at their packaging, make sure the packaging is right, that the label's in the right place, that it's correct label. So those are some of the example use cases that manufacturing are using them for. Medical is using cameras in many different applications. I'll talk about a few in a bit. Agricultural and construction are using cameras a lot, primarily for operational awareness or situational awareness for the operator, as well as in the near future, there are some autonomous vehicles out there now, and there'll be more and more of them. We'll talk about that in a bit. Automobiles and on-highway vehicles have had used cameras for years now for backup. Some of the new cameras have this 360 surround view where you can see virtually what's going on all around your vehicle, and we have a video at the end that will show what that means. Mobile robots are becoming more and more popular, especially in distribution centers and situations like that, as well as autonomous drones, both for in warehousing as well as a lot of construction and ag and other applications are using drones for surveillance. Traffic control, certain traffic control companies use cameras to detect the level of traffic coming from all different directions, the number of people, how many pedestrians, bicycles, et cetera, so that they can do smart traffic control. Outdoor entertainment and sports, there are companies, I believe there's one in Nebraska, that sets up cameras around a sports field and they record everything, and then they use AI to develop all the statistics for the coach. So the coach doesn't have to manually create all the statistics about the game. Parking lot management, cameras help you to understand where vehicles are and where openings are. Recreational vehicles, both on-road and off-road. If it's an on-road, they have for sure a backup camera, but more and more operators want to know what's going on all the way around the vehicle, as well as a camera so you can see as you're hooking up your trailer to get it lined up. Even off-road vehicles like side-by-sides and some other things are having cameras on them now. You might not think digital signage would be a use case for cameras, but if you drive by a digital billboard on a freeway and you look closely, most of them have a stalk sticking out from the display with something on the end of it, which is a camera that's looking at the display, so that they can prove to the advertiser that their advertisement ran at the time it was supposed to and that it ran properly. So some of the applications for cameras are related to safety, for example. Make sure that people have on their proper personal protection equipment. You can detect if they enter into dangerous zones. Um, you can also do driver awareness detection, so you can detect if the driver is drowsy, distracted, on a cell phone, um, smoking a cigarette when they're not supposed to. For example, if they're in a company vehicle that's no smoking, cameras can detect all of those things. Typically need Edge AI along with it. School buses use cameras both to record what's going on in the bus for security reasons, as well as to make sure all the kids get off of it. But they also use cameras to detect a car that's coming up and running the stop arm and record its license so that they can send that to the police. Public transportation is very similar to school bus, same use cases. Talked about traffic control already. Object detection and avoidance. So if you have a construction or ag machine, there are certain things you do want to run over or hit or plow, but there are other things you do not want. You want to be able to detect and avoid. So cameras are one of the sensors that are used in those applications. Autonomous operation, whether it be for tractors, mining trucks, delivery robots, delivery drones, mowers, construction equipment, agricultural planters and sprayers, mobile robots, cars, taxis, planes, trains. All of those things are in development or already available today, and all of them use cameras as well as a number of other sensors to be aware of what's going on around them so that they can operate without human input. Factory automation, I talked a little bit about that already. Make sure that the assemblers follow in their directions. Make sure the components are in the right place and location and orientation. Make sure the pallets are properly loaded and marked. And then detect defects in your final assembled product. One use case I can think of was on vehicles that use hydraulics, and they wanted to be able to detect if the hoses were on properly. And by using cameras, that was one way they could detect whether the hoses had been properly tightened up, because if you have a hydraulic leak, that's a major environmental issue. Agriculture uses cameras in many, many different applications. Been doing this for 10 or more years. There's a company that was based in California, or still based there. It's what recently acquired, but they have a weed sprayer that goes through the field using cameras, looking at every row and detecting what plants it sees. And if it sees a weed, or maybe there's 2 or 3 different types of weeds they're looking for, if it sees a weed that it wants to kill, it will spray weed killer on that weed only, not on everything else. So that allows you to reduce the amount of weed killer you use, which reduces your cost, but more importantly, reduces its impact on the environment. A similar application using cameras to look at the corn or soybeans as you're going through during the summer and injecting anhydrous ammonia, i.e. nitrogen, into the soil. If you look at the color of the plant, it will tell you how much nitrogen it does or does not need. And this application would use cameras per row with an Edge AI system that would make a determination of exactly how much nitrogen should be applied on that square foot area. Another use case is if you're in a combine in the fall harvesting corn, there is no way you can see down into the corn to see what's, you can't even see where the rows really are. So you can put stereo vision cameras down at the bottom of the combine so it can see, and then it can actually guide the tractor or the combine to stay in the very center of the rows for optimal harvesting. They have another use case where, as you're harvesting grain, cameras are used as the grain is coming into the bin to automatically adjust the combine operation to give you optimal grain quality. Object detection and avoidance. Obviously, if you're going through a field harvesting, and there's a deer and you can't see it, you really do not want to run that deer over and get that all ground up with your corn. So you want to be able to detect it and stop before you hit it and allow it to move on. You would want to do the same thing with people and other applications as well. For drivers, cameras provide situational awareness. You can imagine on a combine that there's very little you can see about what's going on the sides or behind you. There are 360-degree camera systems where you'll put a camera at the back two corners and the front two corners of the vehicle, and the cameras have to be in frame synchronization. So they have to take pictures at the same time or frame capture at the same time from all cameras. That information is fed into an Edge AI computer, which will stitch the data together and give you a virtual view of what's going on around your vehicle. And we'll show an example of that at the end of the presentation. Another use case is when you're harvesting, the grain cart comes up next to the combine. Once it's up by the combine, it actually becomes, it links itself with the combine and comes under control of the combine so that it will follow the combine at the right speed. But then on the spout that comes from the combine to load the cart, there's a camera on there, a stereo vision camera, that detects how full the cart is and helps fill the cart uniformly front to back all the way up to the top. Construction is very similar. They need rear view cameras. They want 360-degree view around the vehicle. Several of them are investigating that technology today, and it does exist. And then object detection and avoidance. For example, if you're a forklift, you want to be able to gently run into a pallet and pick it up and move it, but you don't want to run into a dumpster or a stack of materials or something, as an example. Then for medical applications, a lot of applications involve microscopes for capturing images and automating some of the studies that are done with microscopes. Retinal imaging is done with cameras. Motion tracking systems for sports and rehabilitation that are used by biomechanists. They effectively put a bunch of dots on your body with cameras all around and have you, for example, if your runner run on a treadmill, they will record all that, and then the biomechanist uses physics and mathematics to come back and tell you, if you change this movement from what you're doing to this, you will no longer injure yourself, or you'll improve your performance or whatever. Also, pill scales. Pharmacists use scales to weigh out their pills when they're filling a prescription for you. If you have a camera on that scale, it can detect that it's exactly the right pill with the right dosage, the right color, and then the scale will count out the pills for you. So that's another example for medical. There's one that I don't have listed on here, but there was a device that was manufactured that a patient could swallow, and as it went through your system, all the way through your intestinal tract, it would be capturing images, and then it would be captured when it was expelled out the backside. And the doctors, it had Bluetooth in it, so they didn't have to actually ever touch it. They could get the data as it was going through you. Automotive and on-highway transportation vehicles. School buses want this 360-degree view for the driver so that they can see what's going on. The same with semi-trucks. Also, a lot of semi-trucks are involved in backup accidents where someone is hurt because the truck backs up over someone or something. So if you had backup and object detection capability, so you could stop the vehicle from backing up, that's another use case. If you're on a school bus, you want to be able to detect that a vehicle did not stop and take a picture of it. Also, you want to be able to have enough forewarning so you can stop the children from getting off the bus so that they don't get possibly hit by that car. So at this moment, I'll just pause and see if there's any questions. All right. So we're going to move on to some of the types of camera. There's monochrome cameras, color cameras, cameras that will automatically focus. There's other cameras that have set focus and you want to manually adjust it. cameras for low light conditions as well as bright conditions, high dynamic range cameras, cameras with a very wide angle of view, night vision cameras that can see well in low light, high speed frame rate cameras where you need very, very quick information so you can make decisions before you hit something, for example. Stereo vision cameras. I'll talk just a minute. I'll read to you what I learned about stereo vision cameras. These synchronized multi-cameras is where every camera takes a frame capture at the same time. That's needed for a 360 view and some other applications. Infrared cameras, high resolution, near infrared, and then time of flight cameras. And time of flight cameras and stereo vision cameras are considered to be 3D view cameras. A stereo vision camera allows you to, as a human, we use human binocular vision to determine how far something is away from us by looking at, this is all done automatically in your brain, but you determine how far your right eye thinks the object is, and then how far your left eye thinks the object is, and then you do an algorithm that your brain does, and you can have a sense of how far away something is from you. That's how we can detect that, or hey, that car is 10 meters away from us, or 10 feet away, or 100 feet, or at least in the ballpark. So these things allow you to detect distance to things, and the same with the time of flight camera. The difference is the time of flight camera uses an infrared light that it sends out a pulse, and then when it comes back, it can determine how far something is away, and therefore what the distance is to it. So it's another 3D technology, but it's used in a different way for similar applications than the stereo vision is. And then there's 5 primary camera interfaces for digital cameras. Obviously, there's still cameras with analog output, which I didn't list on here, but cameras that are used in real-time autonomous applications. For example, you need to be able to detect that a deer is in front of you and stop and do all of that in less than 1/10 of a second. You're going to use uncompressed high bandwidth interconnect like GSML or GSML2 or GSML3. GSML is the first gen, GSML3 is faster, so each generation gets faster. GSML is uncompressed. It allows you to transmit video, power, and bidirectional control signals over one cable. The cable can be up to 15 meters long, and the cable can either be a coaxial cable or a shielded twisted pair cable. Primarily up to now, coax has been used, and shielded twisted pairs coming into use more now. So why would you want an uncompressed video? Well, if you're using Ethernet, the camera captures video images, then they have to be compressed in the camera, which takes some amount of time, measured in milliseconds. And at the other end, where the camera image comes in, you have to decompress it and expand it back out to its full resolution, which again takes some amount of milliseconds to do. And in that time, you might have already ran over that deer. So if you need really real-time decision making, that's when you use uncompressed video. And GSML has a 3 gigabit bandwidth, GSML 2.6, and GSML 3 has got 12 gigabit per second bandwidth, so they can be very high resolution cameras. Ethernet is very popular, especially if the cameras have power over Ethernet, so that you only have to run one cable to them. The cameras do compress the video before transmitting it, and then the receiving end has to decompress it. So there is, I don't know exactly how many milliseconds, but many milliseconds of latency compared to a GSML or other uncompressed transport capability. If the camera is a PoE, then the switch must be also, but that's pretty common nowadays. If you don't have PoE, then the camera will need a separate power cable as well as a data cable. Typically, these cameras run at 1 gigabit or less, and you can run a 100-meter maximum cable length. USB 3 is also another popular use case. In this case, USB 3 can either send compressed or uncompressed video. Use one cable for video power and control. You have a maximum of 5 gigabits per second bandwidth, and you can run up to 10-meter cable length. Ethernet and USB are quite often used, as well as GSML, in factory applications. MIPI CSI is an uncompressed video, but it's for very short distances. So this would be where the camera was integrated into the system. For example, in your cell phone, the camera module talks to the microprocessor via MIPI CSI. You can only go 15 centimeter though. This is not a long distance. So this is typically where the camera is inside with the computer, and it has 6 gigabits of bandwidth. And then TI has a FPD Link 3, which is similar to GSML. 80i brought GSML to market, and TI brought FPD. They're very similar in that they're the same length, maximum length of 15 meters. They can run on coax or SDP. FPD is max of 4 gigabits per second bandwidth. Other than that, it's very similar to GSML. It's uncompressed data. Okay, now if we take cameras and or other sensors and combine them with an edge AI computer, now we can make intelligent decisions right on the device. All autonomous vehicles or devices require edge AI so that they can make intelligent decisions. All of them that I'm aware of use cameras, but in most cases they use other items as well, like LiDAR, radar, proximity detectors or sensors, an IMU. So if you're out of a GPS or RTK range, you can continue to know where you're at. Cameras and LiDAR are sensitive to dust and can be affected by dust. So typically that's why multiple sensors are used. Radar is impervious to dust. So radar is becoming more and more popular as a sensor for these applications as well. So once you add Edge AI, you can detect objects and you can tell what each object is. Maybe you want to detect the difference between an orange or an apple or a grapefruit or any other types of things. Also, you may want to detect items and say, I don't want to run over that garbage container, but I do want to pick up and basically run into this pallet. And the Edge AI computer needs to know the difference because it's going to avoid you from, it's going to stop you from running into the garbage can, but it knows that you're supposed to put the forks in the pallet and pick it up. People detection is just a subset of object detection. In many cases, you want to know when people are around and you're not so worried about the other objects, depending on the use case. Situational awareness enhancement, backup cameras, 360-degree view around the vehicle, visibility on the sides of the vehicle. All of those help the operator to operate more safely. We already talked about smart spraying for a nitrogen application where they're using Edge AI on the vehicle as it's going through the field. Also talked about defects in products or packaging and keeping a vehicle in a row. And almost every one of these things I'm talking about, one of our customers is doing today or has been for some time, like the combine adjustment and smart unloading. There's actually several companies offer the smart unloading capability. Mobile autonomous robots and drones, and smart traffic control systems, driver monitoring systems, digital signage, and sports broadcasting. So with that, that concludes the presentation, kind of an overview of use cases for cameras. I'd like to show a few videos now. Hopefully this works. This is one thing I forgot to test drive. It's working on loading and then I'll have to switch to There we go. Amanda, are you seeing the video?
The video is loading. Hopefully we'll be able to hear the sound. I'm not hearing any sound. Marty, if you pause it, if you stop sharing and choose to share again, there's an option for including sound.
Okay.
And you'll have to click on that in order for us to be able to hear the video.
Where's the option to select sound?
When you click share at the top, there's like a little toggle for include sound under when you're selecting what screen you're going to pick. Up at the top right hand corner, it says include sound.
I'm not seeing that, but I think we'll proceed with the video because the video is the most important part.
Okay.
Now, if I can get back to it. There we go. Okay, hopefully that gave you an idea what the surround view looks like. That's something that's only been recently becoming available and cost effective. Now let me do the next one. This is going to show object detection. So as you can see here, it's detecting a laptop, a mouse, a pad, a cup, a water thing or water bottle. So this is showing as the algorithm detects objects and the statistics associated with it. It's also detecting the person. The next one will show the John Deere See and Spray product operating in the field. Okay, so that's an example of how it's being used in in agricultural applications to improve both the farmer's outcome and environmental outcome. And this is going to talk about autonomous drones and automated mobile robots. All right, so I'm going to go back to sharing my presentation and we'll wrap up. Okay, at this point, we want to turn it over and open it up and see if there's any questions or any discussion anyone would like to have about what we just talked about. If not, I'll turn it over to Amanda.
All right.
And thank you for attending today.
Thank you, Marty. It was a great presentation.